Right. So, hello everyone. I hope you can hear me well. So, welcome to our first ever YouTube live stream that we have at Green Delta. And we're very happy to take that opportunity of presenting and introducing PSILCA version 3, our social database, to you. So this is the first time that we are basically trying out this new format, and we hope you like it. We're happy to receive some feedback on this. We thought it might be a way of getting more directly into contact with you. But yeah, let's see how it goes today. Thank you very much for participating. So what's the top, or maybe first let's introduce us. We are Pia Lemberger and Kirill Meister, both working for Green Delta as sustainability consultants. Welcome from our side. Well, Kirill has been very much involved in preparing the PSILCA version 3 database, and yeah, we are both going to present it today. So maybe a short note to you, whenever you have questions, feel free to use the chat box. We are looking at the chat box from time to time, and in the end we have like a dedicated time slot for answering all of these questions. I hope that we can really answer all of these. In case we can't, or we don't have enough time, we will definitely answer them later as a comment of the in the video that we will upload on YouTube, of course. So let's start then, I would say. Okay, let's go. So maybe what's the agenda for today's webinar? So as you might know, PSILCA is a database that you use for Social LCA. Some of you might be very familiar with that method, some of you not so much already. That's why we also introduce Social LCA a little, and why PSILCA is helpful for performing Social LCA actually. Then, in the second step, Kirill will very much go into detail about the updates that we have in version 3. He will talk about data source updates. We added some new indicators to the database, and also we implemented a very new approach of calculating social impact, which is more direct and maybe more transparent for users. And I think that's really a great new thing that we would like to share with you also. Then in the third step, we have some showcase to you. We just added, we were looking at one process in more detail, calculating results for it and comparing the numbers between the PSILCA versions. So this might be interesting to really see what has changed. And as a fourth point, we will introduce you into some training and support options that we have on PSILCA and also on Social LCA. I think this will be quite interesting today. And of course, in the end, we have time for answering all of your questions, hopefully. So whenever you have one, let us know via the chat box. So, like I mentioned, I would like to start with introducing Social LCA as a method and application and why using PSILCA for it. So Social LCA, first of all, is a technique that aims to assess social and also socioeconomic impacts, as well positive impacts as negative impacts. So, and the most important thing is that you really assess these impacts over the whole life cycle, like each step. So you're not only looking at your production side, trying to assess the social impacts there, but you really look at the whole supply chain and also the whole end of life in order to detect where there are social impacts occurring for your product. What can this method be used for? used for. So I think there are many applicants, for example, companies, also NGOs or governments, because they're quite wide application fields. I think the most important one that comes into your mind is to use the results for CSR activities. And I think what's really good about performing Social LCA here is that you can do this way more target oriented than you maybe used to in the past, because you really see where in the supply chain or in the whole life cycle, better said, social impacts are occurring. So you're kind of ensuring that you're not taking your resources for something which actually doesn't have such a big impact, because you're missing the impacts that you have in another step in the life cycle. So I think that's really important. Then you of course have risk assessment. I mean, if you for example have a supplier in another country and there's a very high risk of violation of health standards or something like that, there might be a lockdown, and this performing Social LCA helps you to detect that risks. Other applications are of course reporting and labeling. You can use the results for this, or also for strategic decision support. For example, if you plan to plan a production site in a new country, I think it's can be very helpful here. So let's come maybe to the current developments in Social LCA. So there is one guideline on the technical like the technical procedure of performing Social LCA. We call it the Guidelines for Social Lifecycle Assessment of Products. This was published in 2009, and currently the Social LC Alliance is working on it for updating these guidelines, and we're happy to be part of this process with our colleagues. And currently the version 3 of the draft for the guidelines is under revision, publicly under revision. And we are looking forward to have this document available, of course. It's very nice in the screenshot to see that PSILCA is also mentioned as a database that is used for performing Social LCA, and because it's one of the main databases available for this application. So that's how we actually get to PSILCA, from Social LCA to PSILCA. So PSILCA's most important application scenario is performing Social LCA. And the great thing what it makes possible to do is that you don't only have data then for your foreground system. The foreground system is what LCA practitioners call what they have direct control over, or what they have primary data for. So this, for example, if you have a company, your foreground would be a production site probably, because you know about the workers there, you know about the conditions in any, for every indicator, but you might not know this for your whole supply chain, because the supply chains are usually very much intersecting, like they are having an influence on each other, and it helps a lot to take these supply chains into account. And the further you go away from your foreground system, actually, the more intransparent the supply chain becomes. And that's what PSILCA is here for. You basically get generic background data for your system here that you can use for really assessing every step of the life cycle. So this means what it helps us to do is that we calculate and assess social impacts over the whole life cycle, and we can detect social hotspots. So we see where, for which indicator, where there might be a problem occurring. Maybe a fact about PSILCA is that we cover 189 countries, which is quite a lot, and which covers quite a lot of the world economy. And the software is available for use in the open source software openLCA, which Green Delta also developed, and also for CIMA Pro in the starter version. What you see in this slide is just to visualize again how much of an impact it can make to really consider or to take or to use a background database. You see here for the blue lines, you see that there's a high impact that's coming from the foreground system. For all the other indicators that you see at the bottom, for example, child labor or corruption, you see that the background system actually has a higher influence than the foreground system, and that's why it might be very useful to have a look at background data as well. So, this has been the introduction to PSILCA and Social LCA. I'm now forwarding to Kirill to really go into detail about the updates in PSILCA version 3.
Yes, thank you, Pia. Today we're talking on updates version 3.0. So as you can see, there are some changes in compared to the version 2.0. So first of all, we have updated majority of the sources. We have updated the sources which were provided by open databases as Allostat. However, none of them were available as before. For example, laborist data source was used in version 2.0 as the main source of indicators related to worker stakeholders, and right now it's migrated to Allostat. So now it's the only prior source of that kind of information we used. In addition, some of the sources do not exist anymore, they are not supported, or the data wasn't updated, so we had to find other fitting source to replace the data with more recent values. The more recent values has allowed us to achieve broader country and sector coverage. Let's say we have an example of Afghanistan, so we had no information about the country in 2015 and in the sector of textile, but the latest data which was provided by Allostat has achieved us a level of more direct calculation, meaning that we have replaced the data, not that they attributed value, but the real raw value, which increases the accuracy of the final model. As I said, not all of the sources were updated. That's why we took some of the data from the old version of the database, but to indicate that we updated data quality, especially in the way of temporal confirmation. The recent reference year is 2017, and before it was 2015. So any value which is equals 2017 or above the year gets the highest possible data quality score, which is 1. If the value is above quite old, let's say from 2005 or 10, it gets the possible worst score, which is 5. In that way, we can control the data quality, and the final user can know how the reliable data is. In addition, we have also updated risk scales for all indicators. Let's say we had an indicator of a violation of safety standards, which accumulated all the cases starting from 2000 and getting to 2015. However, we are more interested in the dynamics of the processes. So we do not summarize new cases to the old ones. We just take the new cases and we see how do they change through the years, what's the difference in between the years. And in addition to that, we don't take the old risk scale, because if we had 2000 cases and now it's only 20 because it's just simply less cases for 3 years, for 15 years, we would have a quite good result, which is in fact not true. So for that, we need to arrange a new risk scale in order to ensure that the risk levels are detailed properly. In addition to that, we have introduced 7 new indicators, but we're going to talk about it in detail in the next slides. So as you can see in the pictures, there are 7 new indicators. All of them have different level of aggregations. Some of them are main level indicators, some of them are sub-indicators, and we're going to start from the first sub-indicator, which is called domestic and external health expenditures. It is related to society stakeholder in a subcategory of health and safety. So the indicator illustrates a share of domestic and external health expenditures in relation to the total health expenditures. In fact, it's a side indicator which was used mostly for determination of domestic general governmental health expenditures, but however, that information might be valuable in any social LCA, and the user would know which share is coming from both sources and if government are taking the rest from any other subsidies or maybe fundings. So right now we are moving to domestic general governmental health expenditures, indicator of less level of disaggregation, which allows us to know what share is actually funded by the government and how good healthcare in the country is, because we know that usually the country which spend a lot of their own money, not taken from the other sources, I mean the external sources, having a quite good healthcare system, which is quite a key feature right now, as we know during the corona crisis time. The countries who had been investing quite good in their own domestic healthcare are keeping up quite well in comparison to the countries which paid less attention to this area. So the new indicator which was introduced to health and safety is violation of mandatory health and safety standards. The indicator itself will be showcased in details in the next slides. However, I'll just mention that it aggregates all the cases of violation within a certain period of time. In our case, it was 2015 up to 2018, in respect of the total number of workers in a country. In addition, we have introduced a brand new indicator which wasn't even been presented in the subcategory. It's prevention and mitigation of conflicts. So the indicator itself will be also showcased in details. I would also show that it's a final indicator which consists of 25 sub-indicators and was developed in order to cover as much as possible areas and sub-areas of the risk of conflicts. So 3 last indicators are all related to migration subcategory, and we know that actually every one of them equally shows very valuable information. The first indicator is called asylum seekers rate, which actually reflects the share of people who are willing to obtain a refugee status. However, they're not getting it yet due to various reasons, and also it might indicate some possible social risk related to the high number of these people, and of course it might indicate hotspots as well. In addition, the 2 other sub-indicators are immigration and immigration rate. The immigration rate basically might be an indicator of so-called brain drain effect. So people would be leaving the country, somehow damaging the economies, getting the money in other countries and not paying the taxes. Of course, some of the economy would lose from that effect, but however, on the other hand, it might be the opposite effect, is the person who would go abroad would get some experience and of course would get some proper education, get back to his own country, and then boost their own economy by opening own businesses or maybe founding companies. And immigration rate is the other indicator we'll be talking about. Basically, it's indicator of economy exploration based on the low-paid jobs, not only of course, but also a lot of people who are not willing to take their jobs, abandoning some economy areas in the country. However, the new coming people are willing to take any job, and that's the kind of the fitting the gaps. And of course, the other thing would be high-paid specialists in IT, let's say, or maybe in the healthcare area. they are quite a good asset to any development of the economy. So we can, in the same time, observe both positive and negative effects related to the migration indicators. As I said, we'll be talking in details about some of the indicators. So the first one is violation of mandatory health and safety standards. So as I said, the indicator is a ratio between number of accidents and total number of workers in the country. The major idea was to relate it to the sectors, let's say textile industry, maybe a mining industry. However, there was no fitting information to realize the indicator in a way we planned, so we just stick to idea of the ratio in respect to the total number of workers, because the information is quite open and available almost for every country. So the risk could be used to measure overall compliance with mandatory health safety standards, and it might be an indicator of prediction of number of accidents on average. It might be quite a valuable feature when we think of potential risk related to lockdowns due to safety inspections and maybe financial losses related to violation of these safety standards, especially in quite vulnerable sectors. And that might be interested for simple research, which is usually done by NGOs or research companies and centers, but as well for international corporations, which usually outsource production and thinking of the risk related to it. And the next indicator we'll talk in detail is risk of conflicts. So the indicator basically is divided on three large groups. First one is social safety and security. The second one is ongoing domestic and international conflicts. And the third and last one is degree of militarization. All of them are measured by the Global Peace Index, which is basically a sum of different 25 sub-indicators, which then provide a final score which could be used in order to measure so-called ongoing or maybe not that active conflicts. So as I said, it could be also a good asset for the transport companies if they're thinking to organize a transport hub and they're thinking of the risk related there, because not always the cheap labor force and the priority while making decisions. We should also think how stable the whole supply chain is and what the possible issues related to the conflicts. Maybe it's not that huge and they could be considered as a trade-off, as well as if we're talking about large corporations. For example, if the corporation thinking of the implementation of a project, what could be the possible issues during the project implementation and project development? So,
maybe just to mention, don't forget that you can ask any questions in the chat box. I mean, especially now when we come to the direct impact assessment calculation, I think there might come up some questions. We really have a dedicated time slot. Maybe this is also important now to know for everyone who was just joining us. Yes.
Yes, thank you. So right now we are moving to a new feature which wasn't being introduced before. It is called direct impact assessment calculations. It is something new, and I guess it's quite a handy tool. And right now we're going to talk about the main reasons why it should be used, in which cases it should be used. So right before we used worker hours as activity variable. So we're talking about version 2.0 right now, and it reflected the share of involved activities associated with every process. However, there are some issues with that approach, as not every indicator is directly related to the working hours. The problem is that the only stakeholder which is covered and the other stakeholders are not available yet, and it is quite complicated to relate the worker hours to such of indicator as drinking water coverage or door-to-door emissions, because the user cannot directly relate them together, so it leads us into lack of transparency of the calculations, because we don't know how are they really involved in the processes we have in the database. And of course, that creates an issue of data interpretation, so user must create a lot of systems and think of what it really means and what are the possible hotspots. So that is why we thought it would be quite a valuable thing introducing new approach, and it is called direct because we don't use any activity variable anymore. We stick to the total inputs of each process, and we'll talk about it a little bit later on. And we use original so-called raw values in order to assess the impacts. So in this slide you can see the whole idea behind. So it is a simple formula. I wouldn't go too much into the details. I just want to give you a general overview and how is it really calculated. So GK is basically our result of the indicator, which is basically non-normalized yet. But in order to do so, we divided by the ratio down here. So basically, here is the process output of the technology metrics, and it is multiplied by scaling factor. Basically, it is our impact divided by the contribution amount of the total products in the whole life cycle. So we're taking into account the whole amount of products because it's really important to scale it and replace activity variable. And somehow we have the weighted inputs as well as extents. So here you can see a part of the script which is made in Python, which is later on could be applied in the openLCA software in order to go from the worker hours calculation into direct calculation. So here you can see an example of it. So we have a special tool in the developable tools tab. You go to the Python script, Python section, and in this section you can utilize the script in order to perform direct assessment. There's also an idea, as I said, it doesn't use working hours anymore, and it uses raw values, but it means that also we remove risk levels which were preset in the previous version with the worker hours. In order to overcome the issue, there is a second script which would allow a user to assign the risk levels. So the idea is that in the picture you can see it is not the whole script, of course, it's just the part of the script, but I just want to give you an idea how easy it could be tackled by a user. So at the top you can see user inputs, and here you need to specify the indicator you want to change, so meaning the risk levels. Let's say you calculated a couple of systems already and you have various data. In the data you would like to assign a certain range. So you can pick all indicators at once if you want, but however it's more useful if you define hotspots of your analysis and you would pick certain indicators. Here it is children labor, so basically children in employment, labor subcategory, and total, so not divided by genders. And here in the tables you can see several codes, which basically a description of mathematical scheme, which is used for definition of the risk levels. So here in the middle you can see red text, and in the text you can see that, for example, for the very low risk you have any values in the interval starting from 0 and going to 0.5. If you want to change it to any other value, first you need to pick a fitting code. Let's say it is R2. And we know that basically any raw amount should be lower than maximum or equal to the maximum value that you set yourself, or strictly higher than the minimum value that you also change. So in that case, you would need to set R3 to R2 in order to change the mathematical scheme, and afterwards you need to show the new range. Let's say you want to move from 0 to 1 and from 0.5 to 1.5. So basically that is the major idea behind the script and how do you change the risk levels. So here in the picture you can see Casino Steel Industry UK. I know it's quite complicated to see, but it's basically to give you the whole overview. Sorry, so in details you can see the output processes in more detail, and here sorry. Yeah, sometimes it happens that it's too intense. Yes, so here in the example it's a direct impact assessment, because as I said, we're now showcasing the new approach and not the worker hours. So how it looks like right here, here you can see the raw amounts instead of worker hours as it was realized in version 2.0. And yes. So here you can see the main features of the direct calculations. So there are really good reasons to apply the calculations, because as I said, there are not enough of transparency behind the calculations, and we don't need to use activity variable anymore. We just use the raw values, and the user knows what is involved in the final calculation. So it allows us to simplify the process. However, there are some setbacks or drawbacks related to that. We just need to keep in mind that the whole result is now averaged, and the risk cannot considered, unlike in the previous approach of the work hours. And the interpretation of the values for sure depends on the user, because as I said, you can estimate the risk levels yourself, so you need to make a decision what values in what range are related to certain risk levels. So it is more up to a user to decide, and maybe it could be effect of accuracy of the final system. So now we're going into the section of showcasing of PSILCA version 3 and openLCA. So as you can see, it is an example of a developer version. It's an example of processes in Argentina. You can see several sectors: bakery products, auxiliary services, and financial intermediation, and so on. Of course, it is different for every country because it is basically based on the available information, but however, it is pretty good coverage for some countries, and Argentina is one of them. So basically, if you open any process, you would see the same window is here. Out of the window, you can proceed to creation of a product system, and of course, you can also see the location of the process and basically any additional details if given, especially in the description part. So as you can see, there are pretty much a lot of processes links, so it is over 100 million links in between, so it means that you need to have quite a powerful computer, especially while you're dealing with the developer version. And every general system has number of 14,839 processes, but however the total link is quite large, I would say, so you need quite some time to calculate everything. So here in the picture you can see an example, and that example is referred to the old approach. So here in this orange frame, and then in the picture you can see actually worker hours. So it is not the direct values, so-called raw values, it is more raw. It is more work hours which contribute out of each process.
Maybe to add here, we still have both approaches available. So who is very familiar with the work hours approach can still use this one. And yeah, so that's also why we're now showcasing this casting still in UK for the prior version of calculation.
Yes, true. So then if you go into further details, so you can see the list of social aspects. They are also assessed by activity variable worker hours. So you can also see data quality. As I said, for the old values, we have updated data quality. So if you can see that it is 5, 4, or something in between, you can see that it actually quite old data which wasn't possible to be updated. But overall, you can see a list of all indicators which have their assigned risk levels based on the data ranges which were retrieved from the open sources data. So here in the pictures, you can see basically inputs and the outputs of the processes. And as I said, this is special column of the data quality down below. And you can see also according to the color code how, let's say, all the data or not reliable is, so the user would have an expression what kind of the data and how can we treat it and how should we trust it fully, or maybe we should maybe a little bit more accurate with it. So and here is the same slide, so you can see impact analysis relating to different categories. So every category had also included data quality, and here we can see all the impact results. And as you can see, we have the child labor category female, so it is split it in 3 different categories. So we don't treat it as in total the child labor, we treat it as child labor female, male, and of course we have total if you're preferred to be looking at that one. So as you can see in the picture, the process takes into account the whole supply chain. So you see here you can see the map and the countries which are affected by the current supply chain. So basically it is not only the country we're picking and let's say it was sector in UK, it also illustrates all involved agents. So we see the whole supply chain. So here you can see different options. So basically the differences in between starter, professional and developer version. So everything is showcased for version 3.0 exclusively. So as you can see, the yellow line is the starting version. Then it follows by the green line with the pro version, and the blue line in between up to developer version. So as you can see, the differences in versions are basically the accuracy of the calculations, and of course the more sufficient version you have, the more resources it takes from your computer. So sometimes it's quite complicated to make a calculation only on your laptop. You need to think of other ways to do it if you have quite not powerful laptop, of course. So here it is basically the same picture, but it gives us, we can feel the difference more easily. So the left part is the version 2 developer, and the right part all the version 3.0. As you can see, the difference in the calculation, especially for the indicator contribution to the sector and environmental load, are quite different in between 2 versions. So for the whole pack of version 3.0 and the one version 2.0, it is related to more accurate data received during the first stages of development of the database.
And the same actually also for the fair salary. It gets quite obvious here the difference between developer and version 2 and version 3.
Yes, true.
And yeah, what's maybe also nice to see here that you have that it can be that in the 3rd version something like a special indicator is actually rated lower or assessed with lower risk than before, or with higher risk. So there's not only one tendency. So it really depends on the updated data.
Yeah, that's true. So yes, now we're slightly moving to the material training support. So over to you again.
Sorry. Okay, so you might, thanks first maybe, Kirill, for introducing to everything. So you might think now, okay, how can I work with PSILCA? What do you have available for learning here? Maybe first, PSILCA version 3 is not available yet, so we're very soon going to publish it though. We have 3 versions, or we will continue to have 3 versions available: the starter, the professional, and the developer version. You might see, their abilities actually, or their features stay the same, except for the direct calculation approach, which we have now implemented in the developer version. So we think it's good to give this feature to people who are very much involved in Social LCA and work with it a lot, also to get feedback for being able to implement this feature for all variants in the future. And of course, the cutoff criteria remain the same. Kirill actually showed us the differences in the slides. So they stay the same, and all of these variants are still available. So first, it might be maybe also interesting for you to see that there are many researchers and companies working with PSILCA. So we have some case studies and literature here for you. As I have seen in the comment section already, someone was asking if the slides were published, so we will definitely publish them, and then you can use these sources for doing some research and see what kind of studies have been conducted using PSILCA already. What we offer, of course, as soon as the PSILCA version is going to be released, we also release the manual, the respective manual. So we are still updating this one, and it's freely available. Also, which is something that might be interesting to many of you, we are currently working on a case study tutorial for Social LCA that uses PSILCA also. And some of you might know our PET bottle case study tutorial, which is really a step-by-step introduction to environmental LCA, and we plan to have the same for Social LCA to kind of bring this topic closer to you, especially for starters. Also, what's always available is the openLCA forum, so LCA practitioners can always write there, and they will find other practitioners. We, the team of Green Delta, is also very active here. In case you have questions, you can just type the questions there, or even also help others and answer their questions, which would be great, of course. In case this is not enough, there is a support packet, or there are support packages available. You can access them via openLCA Nexus. For example, modular support gives you really, you will have support tickets, or a time-based support that gives you the opportunity to get in contact with a consultant from Green Delta that is able to answer your questions. And finally, I'm happy to announce that we're also planning a Social LCA training. As this is a very specific topic, it might be interesting to many that are just starting here. And we thought, or we set up the training content already. It will be very much about the technical framework of Social LCA and PSILCA as well. But very importantly, we will also conduct a case study with you. So you will go through a case step by step and really apply all all the whole procedure and all steps, really from creating a foreground system, connecting background data to it, calculating and interpreting the results. And in case you're interested in such a training, please let us know. That would be good for, or very helpful for planning. So I just added the email address here. And now we actually have time for questions, would have time for questions. So I suggest that we wait a little, maybe.
Yes.
So in case you have questions now, just type them in the chat box.
Well, I guess we can answer them later on if you never thought about it before, but then it came after the stream. You can write it in the comments section and we reply to them.
Of course. So that's also an option, that you just type your questions out. So in case there are no questions popping up now, then just add them later. That's no problem at all. We will answer them in detail. And yes, I think then that's it for today. So whenever you need information.
Oh, I think we got a question.
Oh yes? Wow, cool.
Yes. How are the indicators in region weighted? Is the first question. And the second question is, when focusing on a single indicator, what is present both in PSILCA version 2, I guess version 2 and 2, I guess maybe it was related to version 3, not to understand, is obtained using PSILCA 2 consistently. Do you understand the one?
1 second, we are just reading the question.
Maybe meanwhile I can try to reply to the first question.
Yes, of course. We
Okay. Okay, maybe we can get back to the slide so it could be more clear. So if you meant that one, it is basically a scaling factor, first of all. So as I said, the products in the whole LCA contribute their own shares to the processes. Every product could have their own share, and in total it is used as a weighting factor. The thing is, for that also we need to determine a scaling factor. And to determine a scaling factor, you need to take the, so basically we have two matrices. The first one is technical metrics and elementary metrics. In the technical metrics, we have all our inputs, and the elementary metrics, all our outputs. So to find the scaling factor, we need to take our technical metrics. Then we need to determine, how do you call this process? Then it's a minus 1, to the power minus 1. Invert the metrics, thank you, Pia. Invert the metrics and multiply it by the demand vector. Basically, the demand vector is the vector which you need, it's your total final amount. So for example, if you are, I don't know, mining coal, so you might matrix, if you have 5 rows in the matrix, all the rows would be zeros except the last one, so which is are to represent the final amount you needed. So in that case it would be 1,000 of the coal, and then you just multiply inverted metrics by the scaling factor, by the demand vector, and then how you have this scaling vector, and then you just multiply all these inputs of the process to the scaling vector. But it's quite more in detail. I can maybe reply later on, but that's the basic principle behind it, and it's done for the script.
So maybe you should not call it a weighting. It's a normalization. So you really yeah, distribute, or what do you call it? Divide your social impact through all impacts of all processes for your respective indicator, and that's how you get to the normalized result here.
So I think we can reply to the second question. So if we go to the question, so to that graph. So you were asking about how they are comparable. So as you can see here in the developer version 2, we have contribution to the sector environmental law about 4.5. So the final value is about 4.5. But in the new versions, with the availability of new, more precise data, we have lesser impacts than in the previous version. So you can say you can compare the data. The same comes to the active involvement of enterprises in corruption and bribery. But the most graphic indicator in that case would be, as we said, and Pia also stated, so the contribution of the sector and environmental load.
Yes, maybe to add to this, for most indicators, they are available in both versions, in version 2 and in version 3, and also for all the variants. So this means for all indicators that you have in both versions, you can definitely compare the results, but we recommend now, of course, to, if you have both versions available, to use the results from version 3, because they are just updated and really represent today's reality in a way. And what's maybe important to consider that in version 3 you of course have additional indicators that have not been considered in version 2 already. So there is no comparison available, of course. But for the rest, yeah, it's comparable.
And the next question was, will we release the demo version for the database for the tutorial? We have mentioned. I mean, the new tutorial, I think, working on.
Like we mentioned, yeah, we haven't actually decided on that if we will have a database with the tutorial, but yeah, it's a good aspect to mention. We will definitely consider that and see what we can prepare. Good point.
And the last question so far, yes. So basically, it is not related on the subjective parameter. It's, as you stated, more, if we can call it, trade volume. So basically, how every product and the whole LCA, what of its share contributes in the final result. So
right. So it does not depend on subjective weighting, right? Okay. Are there more questions? And have we answered all of your questions? Maybe Nemanja, Arthur, and VA, you can just confirm with an OK or something if we have fully answered your questions. That will be good.
Or we take our time to research it in detail and reply later on.
Yes, we can also do that. Yeah, probably there is a short latency in the stream always, but yeah. Thanks. Okay, awesome. All right, I think that it's time to finish today's webinar on PSILCA. Yeah, like we have mentioned already, it's great. Ooh, sorry. So, it's great that you participated. Also, you can also give us some comments on this format. I mean, in the past we had always set up webinars via Zoom, for example, that you had to register for. So we would also be happy for feedback about this new format and how you liked it. And also, yeah, whenever you have questions, let us know via all of the channels that we have written down here. You can, like here, you can access the information. Or we will publish here when we will release PSILCA version 3. We don't want to let you wait, so we are very much working on this. Thank you for your participation. Yes, and see you soon.
Yeah, see you soon. Thank you very much. Until the next time.
Yes.